Let me introduce to you to my members. I am Roshan Satish Kumar.
I am Varsha Murali. I am Tanisha Gobinat.
I am Petriya Singh Thirumaran.
I am Dashini Sunesarandevan.
Today, we are going to conduct an experiment about parachute. The problem statement of our experiment is: does a parachute shape affect its time taken to descend? The objective is to investigate the relationship between different shape of parachute and the time. The hypothesis: a circle has the slowest average descent rate. Now, let's see the variables. The many-planet variable, different shape of parachute. The corresponding variable, time taken to descend. Constant variable, height of the parachute, weight of the parachute, type of plastic, and length of strings. Area of parachute, that is 3600 square centimeter. The materials are binder clip, strings, and plastic. Now, apparatus: ruler, scissor, pen, stopwatch, measuring tape, and puncher. The procedure of our experiment is: determine the type of strings and the type of plastic that will be used to create the parachute. Find a binder clip to attach the end of parachute. Draw the shapes in the plastic bag. The shapes will be regular polygon with constant surface area. Circle, rectangle, and square. Cut the shapes according to the line. In the each vertex, punch a hole approximately a centimeter away from the edge for each shape. Cut 24 pieces of strings 20 centimeters of length. Tie the strings through the holes by the vertex for each shape. Circle as 6 equally spaced strings. After tying the strings, gather opposite ends and tie the strings to the paper clip for each shape. Attach the binder clip to the paper clip. After finding a drop zone with minimal current, be sure to have glass above the ground to the parachute will be open. Line up at the bottom of the object with the mark of the determined height that has been measured. Drop the parachute, immediately start the timer. Stop the timer as soon the parachute touches the ground. Record the result in the data table. Repeat the step 4 times, total 5 trials per parachute. For this experiment, we have chose 3 shapes, which is A square, B rectangle, and C circle. All the areas of the shape need to be same, which is 3600 square centimeter. A is square. The formula is length times width, which is 60 centimeters times 60 centimeters. The total area of the square is 3600 square centimeter. B rectangle. The formula is length times width, which is 72 centimeters times 50 centimeters. The total area of the rectangle is 3600 square centimeters. Lastly, for the circle, let's ask our friend Roshan to explain. Roshan, could you explain us about the circle? Sure, Varsha. The formula for the circle is pi j power 2. Pi times radius square 2. Pi represents the constant ratio of the circumference of any circle to its diameter equal to 3.142. So, we can The calculation for the circle is 3.142 times 33.85 centimeter. The total area of the circle is 3,600 square centimeters.
This is our new innovation model. This mission helps us to draw 3 shapes of parachute in the same time. We create this model because if we drop the parachute manually, it will be affect the time to drop it. Darsha, do you know how does this machine working?
Yes, Janisha. This machine doesn't use electric. Instead of that, it uses air compressor power to work.
The safety precaution of our experiment is we must wear safety helmet along our experiment. We must hold scissors and knife with care. We cannot stand nearby the machine while conducting our experiment. Hand must dry when handling the machine. And it is COVID season. We must follow SOP by having social distance. We conduct our experiment. We already done 3 trials. This is the 4th trial. Ready? 1, 2, 3, drop.
Square, 2.41 seconds. Rectangle, 2.27 seconds. Circle, 2.79 seconds.
If you see here, the timekeepers in each trial are changing. 5th trial. Ready? 1, 2, 3, drop. Square, 2.41 seconds. Rectangle, 2.79 seconds. Circle, 2.83 seconds.
Now my friend Janisha is going to calculate the average of the parachute. Square, 2.31, 2.39, 2.48, 2.41, 2.41. What is the average of square, Janisha?
Average of square parachute is 2.4 seconds.
Rectangle, 2.19, 2.20, 2.25, 2.27, 2.29. What is the average of rectangle, Janisha?
The average of rectangle parachute is 2.34 seconds.
Circle, 2.83, 2.89, 2.78, 2.79, 2.83. What is the average of circle, Janisha?
Average of circle parachute is 2.84. The average time of circle parachute is 2.84 seconds. It's higher than square and rectangle parachute.
This is the graph that we took from our previous experiment. If you see here, the circle has the longest average time, then square and rectangle parachute. We faced a lot of problems while conducting our experiment, and we managed to solve it. Those are, as we continuously drop parachute, we did drop all the parachute consistently. We noticed that the string of the parachute got tangled easily. Every time we hit the engine, that the one got tangled. Then we realized the load of the parachute need to be centered so that the strings would not get tangled. We dropped the parachute. We noticed that the parachute collided each other when there were less gap between. We adjust the gap between each parachute because it's affect the time taken to descend by collider.
Ladies and gentlemen, the conclusion of our experiment is our experiment has supported our hypothesis. The circle shape had the slowest descent and the time of descent higher among other shapes. The parachute with the circle shape will be drag and air resistance acting on the circle shapes than other shapes. Even though the three parachutes had the same surface area,